Hello and welcome to our Insight session. I'm Michael Schaul and I'm a Principal Technologist at the Cloud Data Services Office of the CTO. And today we're going to discuss about running your EKS stateful workloads with FSX for NetApp ONTAP. So first of all, please read this confidentiality notice and follow its directions. You should know this from other Insight sessions. And our agenda today is going to include a few topics. First of all, we're going to cover the why we even want to run, or why are we discussing stateful applications running on Kubernetes. Then just a quick overview on Kubernetes, about Amazon EKS and what is this service, and then about our own cloud storage solutions, about the NetApp cloud storage solution, and an overview about our topic, FSX for NetApp ONTAP from AWS. A quick review of some storage features that you're going to get when using this storage solution, and what binds everything together and is going to be part of our demo today, the NetApp BlueXP platform. So then we're going to deep dive into the architecture. We're going to review the container storage interface that is part of Kubernetes and how Kubernetes integrates with storage. We're going to review our own NetApp Astra Trident plugin for the CSI integration. We're going to see which type of CSI features we're going to enjoy while using AWS FSX for NetApp ONTAP. And then we're going to review how things are going to work, how about the different phases of the storage allocation, deallocation processes. And in the end, we're going to see a demo how to bind everything together easily with the NetApp BlueXP platform. So let's start. So why do I even discuss this storage for Kubernetes and a stateful application on top of Kubernetes with you? Well, it seems that Kubernetes was born as a stateless application solution, but as time went by and it was becoming the favorable, application, containerized applications, runtime environment, deploying applications easily on top of this platform, then there was a growing requirement from the community to run more and more stateful applications on top of this platform. And you can see this demand growing year by year with the CNCF, the Cloud Native Computing Foundation, and the community requests for more advanced storage features and more easier storage solutions to run the stateful applications. Here you can see the 2020 report, but you can also find that in the 2021 report. So as I said, so Kubernetes was sort of initially designed for stateless applications. So let's do the differentiation between what is stateless and what is stateful. So stateless application is sort of your web service, your application server that runs without any logical dependency on the state. So it mostly does presentation and processes and processing of your business logic. So it doesn't rely on state, and this is where mostly Kubernetes was born. And you can hear a lot of people still claiming that you should run only stateless applications on top of Kubernetes, but we see the market doing, different things. And as I already showed you, the community is requesting more and more stateful. So what is stateful? Stateful applications is the exact opposite. It's applications that deeply rely on and depend on data. So they run with the data. It's like databases or applications that need to save application files or any media or things like that. These are stateful applications. And when running stateful applications, nothing changes. So we're used to running stateful applications on our servers before there were containerized applications. And now if we want to run them on top of a containerized platform, then we still need the set of features and the flexibility, the scalability, the resiliency that our stateful application required before running them on a containerized environment. So there is sometimes some like a misconceptions that things just handle themselves on a containerized or a Kubernetes environment, but the challenges remain, and sometimes they're even harder when running on this hugely scalable, flexible environment. So we still, if we're running stateful applications on top of Kubernetes, we still need our flexibility and scalability, ability to scale our stateful applications, our storage performance, the capacity without a dependency on our applications. So we want to be able to scale our application servers differently than we scale our storage, because they're usually not dependent with one another. Sometimes we need more processing, sometimes we need more capacity. We still need our data resiliency because we run our business on this data, and we need it to be seamlessly protected when we run our stateful application on top of our Kubernetes solution. We need it to be resilient in the cloud, within availability zones, within regions. We need to be able to protect from data corruptions or any data loss issues. We need advanced capabilities to like deduplications, like clones, like seamlessly automate our storage functions. So this is another thing that we need. And also we want to be cost aware, and we want to have our this is a cloud environment, this is a highly scalable environment, a Kubernetes environment, and we want to be aware of costs so nothing goes wild and we don't end up paying lots of money for storage we don't need. And even if we need it, we want it to be cost effective, using features like thin provisioning, deduplication, compression, which we're going to see later on. What is Kubernetes? I don't want to extend on that, because if you're in this session, you probably know and familiar with Kubernetes, but as you know, is an open source project that is designed to run containerized applications at scale. It can run on-prem, it can run in the cloud. And one of the examples of managed Kubernetes we're going to review in this session is Amazon EKS, which is, in a few words, a managed service that Amazon provides, Elastic Kubernetes service that manages the Kubernetes management plane for you, so you don't need to install, run, manage all the management planes components, and also automate the deployment of nodes to run your applications with high availability and advanced functions. So this is Amazon EKS. And the other part of our presentation is the stateful layer of storage that we're going to run, and this is going to be based on ONTAP, NetApp ONTAP. So we have lots of different services running on different cloud providers, although our session today is going to discuss Amazon and Amazon FSx for NetApp ONTAP, which is a fully managed service offered by AWS and is a full-fledged ONTAP solution running in the background, but is fully managed, fully consumable from the AWS console. We do have other solutions in Microsoft Azure and in Google GCP as Azure NetApp Files and CVS in Google, and also Cloud Volumes ONTAP, which is a software solution that runs a fully fledged ONTAP on any of the public cloud, and our own platform will manage this service, but this runs on your VPC and is a service offered by NetApp as opposed to Amazon FSx or the other solution, which are first-party services. So as I said, our topic is Amazon FSx for NetApp ONTAP as a backend storage for EKS, containerized stateful applications. So what is Amazon FSx for NetApp ONTAP? As I previously said, it's a fully managed service delivering both block and file storage. It is a fully fledged ONTAP system behind the scenes when AWS is managing the service fully, and you can consume it from the AWS console, and you're paying AWS and you're using AWS CLI, AWS SDK, or whatever way you want to manage your AWS services, but you still can enjoy all the richness of ONTAP storage features and integrate with other NetApp cloud data services as well. So just a quick review of this is a very swamp slide with lots of different features, but in general, as I said before, when running containerized applications, you still need their robustness and you still need enterprise feature. Nothing is changed from when running your stateful applications on a server. So we're still when running FSx for NetApp ONTAP, as I said, you're getting the fully fledged ONTAP operating system as a managed service, and you're getting the automated great storage feature. You're getting the multi protocol, so you can do both block and files for your stateful containerized applications. You can have performance and scalability, so petabyte scale storage, independent on the amount of servers that you need to run your EKS servers, and throughput, availability and resiliency. We discussed that. You want that in your solution, so it can be a multi-AZ solution. If you need that, you can do cross-region replication, etc., etc. So we won't review everything here today, but just for you're getting all these features. Most of them you don't need to do anything; they're just there, and you're enjoying them. And the last part of the puzzle is the NetApp Blue XP, which we mentioned, which is the NetApp management platform for all of our data services. So here we're going to see in the demo how we will be able to bind and automate everything that we mentioned here today, how we can join or combine our EKS cluster with an FSx storage easily, together with NetApp Trident, the CSI plugin, which is we're going to discuss, just with some drag and drops and pushes of buttons. So it's very easy, and it also allows us to integrate other NetApp cloud data services with our FSx storage solution and our EKS solution. So let's deep dive into the architecture. So we mentioned that we want to integrate our FSx storage with our EKS cluster. So how do we do that? So Kubernetes allows integration of third-party storage with a CSI, container storage interface. This actually, Kubernetes doesn't have a storage solution integrated in it. So this is why CSI was developed. It's a set of APIs that is part of Kubernetes for like storage allocation, deallocation, snapshots, volume extensions, but nothing is, behind the scenes. So Kubernetes expects third-party storage solutions to integrate with these sets of APIs. In our case, our own storage solution or our own CSI driver is called Astra Trident. So this allows us to create the integration using the CSI APIs with different Kubernetes solution, either vanilla or managed solution like EKS that we're going to discuss today. And in the back end, connect our ONTAP based solutions like AWS FSx for NetApp ONTAP or CVO, which we mentioned here, but also ANF and CVS in Azure and Google. So when creating this connection between an EKS cluster or any Kubernetes cluster with FSx for NetApp ONTAP, which CSI features am I getting? So actually, every single one of them, or at least 99% of them. So you get to do storage allocations and deallocation. You can do attach detach, so attaching the storage to the container and the servers, the servers that run the containers. You get both block, file, and raw block devices for your applications. So these are the three types of storage that Kubernetes supports. So you can do that with NFS or iSCSI. We also support volume expansion, both for block and file. So even for block devices, you can expand the volume and the file system in the volume automatically without any need to do anything. Everything happens behind the scenes. That's like magic. We support multi-access volumes and also single access volume, both for read and write. So you can do that if you need to shared volumes, like with NFS, if you want to share your volumes with several different applications, you can do that. Also, for data protection features, we support Kubernetes snapshots with our own snapshots in the backend. So you get the efficiency of the NetApp snapshots. You can do also PVCs from snapshots. So these are Kubernetes clones. So you create a new volume based on a snapshot which you took earlier. So you can do that, and in the backend we run our highly effective Flex clones in the backend. You can also get topology awareness if you're running a multi-AZ environment, so you can allocate the storage in the AZ that the pod gets scheduled on, so the storage gets gets near the pod in a multi-AZ environment if that's something that you need. So we also support that. So let's review the storage provisioning process with Kubernetes and how this is going to happen with together with Trident and our BlueXP platform that we're going to create this integration today with EKS, our BlueXP platform, and Trident and FSX. So generally, the process would require you to start and installing the CSI plugin, so our Astra Trident, and do the configuration of the backend storage, in our case, our FSX for NetApp ONTAP, connecting, pointing to the file system, doing some configurations. You can add one or more of these storage backends, so you can connect to several FSX file systems, or you can connect to some FSX and some CVO file systems. And then you would have to define a storage class, which is a Kubernetes entity of different type of storages that you want to consume. So then you define a storage class, and then what happens is a user creates a PV claim, so a persistent volume claim, with the size, the access type, and the storage class type. So he will use one of the storage class we previously created. And when that happens, Trident would, listen to the request and handle these requests. It detects the creation request for the PVC. It finds the proper backend storage to accommodate for the storage classes that was requested, and creates the volume within our FSX file system, and then binds the persistent volume claim with a persistent volume, which is the physical manifestation of a volume within Kubernetes, and then mounts the volume to the server and the container. So all of that sounds very confusing, lots of actions to do, but in real life, what's going to happen after our demo, and if you deploy everything how the same way I'm going to show you today, is that most of the stuff is automated. So the first parts, the installation, the configuration, the definition of the backend storage class, is going to be handled by the BlueXP platform. It's going to be fully automated by just the press of a few buttons. And then the request, of course, this is something that's going to happen from your developers, or maybe automated processes from your CI, CD processes. That's fine. But then everything else is going to be handled automatically by Trident. So the detection, everything that we mentioned here is fully automated by Trident. So eventually, all you need to do is just allocate storage. So you don't need your developers just need to allocate storage. Everything else is handled either by Trident or by our BlueXP platform. So now let's review the architecture of the demo that we're going to see today. So we can see our AWS environment. We have an EKS cluster running a multi-AZ deployment. You can see that here. We have an FSX file system, spans also on multi-AZs. Yeah, you can see that stretched, and data is replicated between the two AZs for high availability, as we mentioned. And we have our pods deployed, and they're going to be consuming, PV claims. They can be either file or block, right? And then each PV claim that gets created is associated with a storage class, as we mentioned, and eventually Trident will create automatically a volume within our FSX file system, and that volume gets all the benefits that we mentioned. Everything here is going to be orchestrated by our BlueXP platform. So the creation of the FSX file system, the connection of the EKS cluster, and the creation of the installation of Trident, and the creation of the storage classes. Everything else, which is just the volume creation, is going to be run manually within Kubernetes, which is very simple. So let's go to our demo and review all of that. This is our demo environment. You can see our FSX file system. You can see it's an HA deployed between two availability zones. Now let's find our deployed EKS cluster in the same VPC. This is our EKS cluster. It was as well deployed on multiple AZs on the same region. Now to our cloud manager, we'll create a new working environment, choose AWS as a cloud provider and an FSX, and we'll discover an existing FSX file system, the one that we just saw on the AWS console. We'll select the region, US East 2, and we can see the file system which we created, and we'll add that to our canvas. Now we'll add another working environment, this time the EKS cluster. Let's discover a Kubernetes cluster next, and discover a cluster in the same region, US East 2. We're going to see the EKS cluster and click next. And now we also have that added to our canvas with some action required. Double click on that, and we're going to see the actions that we need to do. First of all, install Trident, so installing the CSI driver, which we discussed. So at the push of a button, we're going to have that deployed onto our EKS cluster. Takes a few seconds. Now that when Trident is deployed, we're going to add our first storage class. So we can give it a name. We can create either a file system, an NFS file system, or a block device. And if it's a block device, select the different types of file system. Can support volume expansion, which we mentioned, or wait for first consumer. Let's go next. We select the backend storage, in this case our FSX file system, which we added to the canvas. And that's it. We can now go ahead and create volumes in our EKS clusters using FSX with this newly created storage class. So let's go ahead and do that. We're going to go to our Kubernetes CLI. Let's see our storage class and see that it's actually was created in the Kubernetes. So we can see our FSX storage class that we just created through the Cloud Manager platform. And we're going to create a new volume using this newly created storage class, a 50 gigabyte volume. Okay, let's display this volume. And we can see that the volume was created using this storage class. This PVC was created. Back to our Cloud Manager platform, we can see that we're now consuming 50 gigabyte. We can select view volumes and see the volumes we created through Cloud Manager with the storage class. If we want, we can also enable backups, but this is not in the content of this presentation. You can see the connection that we created. You see this Kubernetes line. And if we go to the FSX file system, and we can see this volume there as well. Trident PVC. So what are the key takeaways from this session? So we've learned how to run stateful applications on FSXN and what are the advantages of doing so. We've learned what are the different tools and services which are required to run our stateful applications on EKS with FSXN. And we also learned how to completely automate the process and make it a very easy process with our NetApp Blue XP platform. Thank you for joining me on this session. I'm Michael, and you can contact me if you need and if you have any questions in this email. Please enjoy the rest of your conference. Have fun.